Welcome to Chapter 3 and a return to algebra. Now the good thing about much of the algebra in this chapter is you've already been doing it. So I'm fairly confident that you are going to have a lot of success with this chapter. In exercise 301, solving equations, you've heard me talk a lot about forming an equation and going on to solve the equation, get the pronumeral by itself. And that's all this exercise is. So, like I said, I think you're going to have a lot of success with it. Just a little bit of a formality before we start some questions. An equation is a mathematical statement that says that two things are equal. Now, the two things, if I just highlight them here, in this example, obviously you can see the equal sign in the middle. So one of the things, or we might choose to call it this left-hand side, is an expression. It's got a number, it's got some brackets, and we'll learn what to do with those, is equal to, and the right-hand side, in fact, is fairly straightforward. It's just a number. So we've got some algebraic terms, which we would have to have, and we've got some what we will refer to as constants. 16 is a constant because it can't ever be anything else other than, in this case, negative 16, whereas C is a variable. It can vary, and it will change value depending on what the statement is that it belongs to. So, to solve an equation, we have to find the value for the variable. Finding the, getting the variable or the pronumeral by itself and finding its value. How do we do that? We shuffle things from one side to the other. Or, as you'll see in this case, we will expand the bracket. Or, as you'll see in this case, we will remove the fraction. So lots of math skills that you've already practiced, you will be applying depending on the question. And we work away until we get the equation by itself. That's so important to realise, where are we heading with this? Already you can see with this one, we will want our last line to be C equals. Here, we will want our very last line to be M equals. This is a good example just to focus on for a moment, because you can actually see that we have two M's, which means we've got to get them together and simplify them down to a term with just one M in it. Oh, sorry, a term with just an M in it. Now, this blast tells us that to solve an equation, it can only obtain one type of variable. So I'd say the variable type here is M and M. It's not like they're an M and an X. We wouldn't be able to solve an equation if we only had one equation with M and an X in it. You can see here we have two variables, two pronumerals, but they're both D, which satisfies this statement that it only has one type of variable. So let's have a look at this. We're going to focus on what we've got to start with, and that should always be your focus. What do we have? Because, like you saw in previous chapters, no two questions seem to be the same. So the process that you need to follow depends on the actual question that's presented to you. The process that we'll follow to do question 1 will be different to what we'll do in example 2 here. So more than trying to just follow a process, we have to think about what we've got, where we're going, and how we will do this shuffling. And because the shuffling will be different, then we need to also establish why we are doing what we're doing. So expect me to place a lot of emphasis on why we are doing what we're doing, and then subsequently you can expect lots of questions about why we're doing the mathematical process that we're doing at any particular time. So if we go back and look at example 1 now, we've already established that our very last line is going to be C equals. So if we're thinking about what we're presented with here and where we are heading, we've got quite a few things to remove or shuffle away. So I think that most people would look at that and see that there are brackets there and would probably want to expand the brackets. The other option is for students that realise that 8 bracket is 8 times the bracket equal minus 16. Some students won't expand the bracket, but they will remove the 8 immediately. How do I remove the 8? I divide both sides by 8. And why I can do it is because the 8 is separated from the bracket by a multiplication sign. The only time you can divide to remove a term is when your terms are separated by a multiplication sign. Expect a question on that. Okay. I'll run the two solutions side by side. Here I'm going with the student that says, I just want to expand the bracket. 4 8s are 32 and 8 2s are 16c is equal to minus 16. The student that says now, I know I can't simplify 32 and minus 16 because they are not like terms. Can't subtract unless you have like terms. These rules sound familiar? They should be. So I've got minus 16c, I've got minus a 16. The term I want to remove is the 32. I'm going to take it over to 16. Two things happen, it becomes a minus. And the other thing that I've created is I've got two terms that can be simplified. So you can see that gives me minus 16c is simplifying these to minus 48. Remember I just said when we want to remove something, then if we've got two things being multiplied, and minus 16c is the shorthand way of writing minus 16 times c. Because we've got the multiplication, we want to remove the 16, thinking about we're heading just to getting c by itself. So we will divide by minus 16 to both sides and get that c. Oops, I probably don't need that line. A negative on a negative is a positive, and 48 divided by 16 is 3. You can see now that I've completed the steps for the solution that had divide by 8 as the first step, and that just left the bracket once the divide by 8, and the bracket is 4 minus 2c. Simplifying the calculation on the right hand side gives negative 2. Focusing on wanting the negative 2c only, 4 gets taken to the other side. Negative 2 subtract 4. It changes sign. It gives negative 6. Negative 2c has a multiplication sign in it, so we divide by negative 2. And dividing negative 6 by negative 2 gives us 3. Same answer. Let's move on to example 2. Now, no brackets in this example. However, we do have the complication of two complications. We've got a fraction and we've got an m on two sides. We know that we will have to bring the m's together so that we can simplify them using our basic simplifying algebraic expressions rules. Take the 5 to the 7, because then we've got numbers, constants together. And we also have the fraction to deal with. Hopefully you remember the rule that says that if I've got divide by 2, the way to remove it is to multiply by 2. Now, the other rule you need to also remember is if you multiply this term by 2, which will be great because that will remove the fraction, then you must multiply this term, and this term also by 2. Simplifying then after doing the multiplication, nicely removed the divide by 2, removed the fraction, exactly what we wanted. But don't forget, you must do 5 times 2, which is 10, and m times 2, which is 8m, and 7 times 2 is 14. Now, our next problem to address is that the m's are on both sides. In this case, I'm going to take this m over to the 8m. So 8m is going to stay, but m is going to come across and become minus m. That places together 2 terms that I can simplify. They're both m's, I can simplify them. And remembering your basic algebra, 8m take away 1 leaves 7. Here I'm going to keep my plus 10, and I'm going to bring 14 over, remembering that you change the sign, and I end up with 28. Back to process you saw, or situation you saw in the previous example where you've got m being multiplied by 7, means we can divide it by 7 and do that to both sides, and we end up with m is equal to 4 from 28 divided by 7. I'm actually going to stop the video there and do the next 2 examples in a separate video.